has always been an essential part of our education throughout our life. Scientists have proven that mathematics help with the development of the brain by improving its ability for critical thinking. Therefore, mathematics brings a significant value in our lives. However, the journey of learning mathematics is no picnic. It's quite challenging and difficult for many students. Hence, many students fail to see it used and find it particularly hard to relate the more complex formulas of mathematics in daily life. In order to show the relevance of mathematics in our day-to-day life, we have set our several case studies on everyday problems in which we will use mathematical methods to solve. As student of CFS IIUM Kuantan, we have identified a few problems here, such as the abnormal heights of speed bumps around the campus and the roundabout sprinklers which spray water out of its designated area.
So let's talk about case study number 1. Case study number 1 will be talking about the coordinate geometry.
Yes.
So what is coordinate geometry? I'll pass to Michael.
Okay, so basically coordinate geometry is one of the most important exciting ideas in mathematics. It provides a connection between algebra and geometry, two graphs of lines and also the graph of curve. It spreads in all fields like trigonometry, calculus, dimensional geometry, and etc. All the subject has obvious application in statistics and physics. It can be applied in real life or the construction field. For example, constructing and renovating the speed bumpers. As IIUM students, we are to renovate speed bumps that have been damaging low bumper cars in the campus by using this coordinate geometry.
Yes.
Okay. So, Afi, what is the problem about these speed bumps and how to solve this by using the coordinate geometry?
So the problem with the speed bump is the height of the speed of the speed bump. It's at a height where it damages cars with like low bumpers.
Okay.
And so to solve this, we should measure the height of the current speed bump and also the width, and calculate for the new measurement using the coordinate geometry formula. So to conclude this case study, in a nutshell, the study emphasizes the importance of a suitable height of the speed bump, prioritizing drivers' comfort driving through the speed bump. And so here we have two figures. The first one is the figure of the bumper we measured in the campus. The height of it is 15 centimeters and the width 350 centimeters. The second one is the figure of the planned to renovate speed bump, which is 7 centimeters in height and 400 centimeters in width. We have to draw figure 1 on an axis. So here we draw the x-axis and the y-axis, and then we draw figure 1 on it. So first we have to identify the coordinates for this point, for the point of from the origin to the peak of the bumper, which is 0 and 15. And the other point that we need to find the coordinates of is the point from the origin and the edge of the bumper, which is 175 and 0. And then we draw the line of gradient so that we can identify what we're going to measure. And so to get the gradient of this figure, of this bumper, we use the formula m equals y2 minus y1 over x2 minus x1. So simply key in, apply the coordinates into, identify the which coordinates is which, and apply it to the formula as shown. Therefore we get negative 0.09. So after we've found the gradient for figure 1, we can move on to find the gradient for figure 2. So draw the axis. And after, draw figure 2 on the axis. Identify the locate the coordinates. That is important, which are the ones we did on figure 1. So, and draw the line of gradient. Use the formula as we did before. Identify which coordinate relates to the formula. Apply the coordinates into the formula. Calculate it, and the answer should be negative 0.04. And that's the gradient for figure 2. Yes. So to conclude, we can see that speed bomb 1 has a higher gradient than speed bomb 2. And what we can get from this is that speed bomb 1 would cause damage to the bumpers of cars, the lower bumpers of cars, and that to solve that, we use the design of speed bomb 2, which has a lower gradient, which stops the bumpers of cars from getting into contact with the speed bump. And so this is how we can use coordinate geometry to modify our bumpers, to modify the speed bump to stop the damage of cars. And
now we proceed on the trigonometry. So trigonometry simply means calculation with triangle. That's where the tree comes from, and it is the study of relations in mathematics involving length, heights, and angles of different triangles. So trigonometry spread its application into various fields such as architects, surveyors, astronauts, physicians, engineers, and even crime scene investigators. For our case study, we are to find a solution to a water sprinkler that sprinkles its water over the range of the area of vegetation. This leads to the wasting of water. So the problem is the water is exceed the vegetation area, which give bad effect to pedestrians and drivers, such as potential car accidents. So from the problem, so we came up with the procedure. So the first step is using a measuring tape. The original radius of the water sprinkler at the roundabout of the specific spot, which is in front of the principal Talha house, was measured, and then the distance of the water that exceed the vegetation area was measured. And the third step is the vegetation area was calculated using the area formula, which is area equal by pi r squared. So next, by enlarging the vegetation area, the water will not spray the walkway.
Okay, so if you look here, this is the area of the vegetation of the roundabout. It's approximately 8 meters. And the water sprays out of the roundabout, which is around 0.3 meters. Okay. So what we decided to do is to increase the vegetation area so the water sprays within this area. So we decided to use the formula area equals to pi r squared. And so area of the roundabout equals to 22 over 7 times 8 squared, which is equal to 201 1 over 7 meters squared. So this is the original radius of the roundabout. So we decide to add the 0.3 to the radius of the roundabout, which is 8 equals to 22 over 7 times 8 plus 0.3 squared. This is equal to 22 over 7 times 68.9, which is the total is 216.51 meters squared. So this is the new area of the new vegetation area. So this is our solution for this problem. In order to know how much exactly plants, the grass that we need to plant, we have to know this, right? How much the area of this whole thing. So we just minus the original radius with the minus the original radius with the new one. So it's 216.51 minus 201 over 7, which equals to 60.36 meters squared. This is the area of the grass that we have to plant.
From Islamic perspective, we are encouraged to do good in every aspect. As a Muslim, we have to be aware of our surroundings. For example, if we see something that is harmful, we must try to prevent it from affecting others, because in Islam, it is considered as an act of worship. So related to this issue is the speed bump that is located in IIUM that have disturbed certain users who drive low bumper cars. Moreover, if we do not solve this problem, it might lead to accident. From that, we as a responsible IIUM students have provided a solution for this issue, which is to renovate the speed bump to a measurement that would prevent low bumper cars from hitting. As I mentioned in a hadith, Abu Barzah report, I said, a prophet of Allah teach me something that will benefit me. So the prophet, peace and blessing be upon him, said, remove harmful things from the roads of the Muslim. So, for example, if we see something that blocking our way, such as this, we just take it and keep it at the right place. See, it is easy, right, to do good. Back to the second issue is the water sprinkler. In Islam, water plays a crucial role in Islam. A Quranic ayat mentioned about the limitation of not by extravagance. Verily, Hila is not al-musrifun, those who waste by extravagance. Al-An'am, chapter 6, verses 141. We should also consider the same when it comes to every aspect of ibadah. So, a good example is not to waste the water used in a water sprinkler. Therefore, we need to design a building or things that will be help others and not lead to wasting. So, in conclusion, it is undeniable that mathematics is an intrinsic part of problem solving, investigation, testing, design and analysis. We also discover how mathematics is related to our surroundings and involved in our daily lives. When we are creating or designing something, we need to consider the suitable measurement, dimension and the comfort of users. Similarly, in Islam, one of the principles is helping the works of the others. Hence, it is required that we try our best to help each other so that Allah will help us.